Hi there, this is Jackfar with a new video, and in this video we will further understand the concepts of mutability and immutability in Python. So last video I've explained that Python variables are essentially pointers to a memory location. And here I will further explain how we can then copy, how we can deal with copying lists. So when we create a list, that list will be assigned to a memory location, and a way that we can copy a list is by assigning to another variable. However, this is actually not copying. We Because when we assign fruits2 to fruits, both variables are actually pointing to the same memory location. So if we change one of them, if we append anything to fruits, that will affect fruits2. Now, a way to prevent this for non-nested lists is that you can use the function copy, and this will create a new memory location. We can also use slicing, same effect, and also we can import the module copy and use the function copy. So all of these three ways will ensure that the two lists are decoupled, so they are not anymore couples, and if you change one of them, it will not affect the other. For nested lists, the situation is different. So when we have a nested list, so we have a fruits.amount, which contains two internal lists, and of course this will get its own memory location. And what will happen is that the internal lists will be pointing to their own memory location as well. And if we now use a copy function, what will happen is that the external list will get its own memory location, but the internal lists are still pointing to the same memory location. So if we change one of the internal lists in the fruits underscore amount underscore CP, so the new copy, if we change anything there, what will happen is that it will affect the original list. So this is called shallow copy. And for a nested list, we need to, if we want to decouple the two lists, we need to use a deep copy. And what that means is that when we create, of course, the lists again, they will be getting their own memory locations, but we can import from copy module. There is a function deep copy which we can use, and what this function does is that when we deep copy the lists, the internal list will get its own memory location, but also the internal lists will be copied over, so they will get their own memory location, and the values will be copied to the new memory location, which means then the two lists are totally decoupled, and if we change one of them, it will not affect the other one. So this is a way we can decouple the two lists. So let's summarize what we have learned so far. A deep copy makes a complete copy of an object or data structure. So it will traverse to the sub-elements and copy everything to the new memory locations. However, a shallow copy makes a new object, but it keeps the same deep elements within it. So the internal elements are pointing to the original memory location. Let's now switch to the editor and understand this practically. So let's now create a new list of fruits and check the ID, and of course it will get its own ID. And if we copy fruits 2 will also be pointing to the same memory location. And if we append anything to fruits 2, this will affect both lists, and this is because lists are mutable. So the way we can avoid this is by the three different scenarios I've explained. So the first one is then we can use the copy function, And we can see that both functions have, both lists have now their own separate IDs. So they won't, a change to one will not affect the other one. Another way is using the slicing, and this will also ensure that fruits2 gets its own memory location. And the last is that we can import the module copy, and then we can use the copy function. And of course, fruits2 has got, it is again a new memory location. And if we update fruits2, this will not affect fruits. So if we check fruits, we can see that it has not been updated, but fruits2 has been, of course, updated. Let's now understand how we can copy a nested list. So we have a list which contains two other internal lists, and if we use the copy function, and if we use the copy function, we can see that both fruits and fruits copy have got their own IDs. However, if we check the internal lists, so let's check ID fruits. So the first list, and let's check the same for the copied list. We can see that these lists are actually pointing to the same memory location. So if I append something to this list, we can see that this also affects fruits amount list. So mango is added to here as well. However, if we add something to the external list, so I can add something to the list, the copied list, dot append. If I add let's say, so I've added now something to the external list, you can see that this will not affect the fruits amount list. And this must have affected the copied list. So this means that if you add something to the external list of the copied list, it will not affect the original list. But if you change any of the internal lists, this will affect the original list. And that is what it means, what shallow copying means. So let's understand now how we can prevent this by using deep copy. So now we have again the same nested list, but now I will import the module deep copy and use that module to copy the list. So what will happen is that also the internal lists will now get their own memory location. So if let's check the ID of the original list, and it has this ID, and if we check the copied list, it will have also its own ID. But if we check the internal lists, so let's start with the first one. This is the ID, and if we check the first internal list of the copied list, it will have its own ID. So this means that any change we apply to the copied list will not affect the original list. Now let's see the original list. And we can see that it has not been affected by the change that we have applied to the copied list. And this is what deep copy means. So if you want to ensure that the two lists are decoupled, you have to use deep copy instead of shallow copy. Thanks for watching the video and see you next time. Bye.